Our first question for lesson 7-4 examples is number 1. What is the geometric mean of 4 and 18? Remember that the geometric mean needs to satisfy this equation here. So for 4 and 18, we need to find the number x that satisfies this proportion. So 4 over x is equal to x over 18. So the way we're going to solve this is to cross multiply. So we get 4 times 18, and we need to set that equal to x times x. So 4 times 18 is 72. And again, we set this equal to our value of x times x, which is just x squared. So our next step is going to be to square root both sides so that I can undo the square that we have there. Now, since 72 is not a perfect square, we need to think, what are the two factors of 72 that we can use? Preferably, we want to find a factor that is a perfect square. So we know that 72 can be broken down into 36 times 2. Now, 36 is a perfect square, and the square root of 36 is 6. So we get 6 square root of 2. We left 2 underneath the radical because we couldn't take the square root of it. So we get, again, 6 times the square root of 2 is then equal to x. So the answer to this question is that 6 square root of 2 is the geometric mean of 4 and 18. Our next question is number 2. What similarity statement can you write relating the 3 triangles in the diagram? So the first thing we're going to do is identify all 3 triangles that we have. So the first one we have here is ZXY. So I'm going to rewrite it below. Now you'll notice that this triangle has an altitude YW. So that means that this altitude divides this bigger triangle up into 2 smaller similar triangles. So we also have this triangle here in blue. So I'm going to redraw this, and I'm going to make sure that W, our right angle, goes in the bottom right-hand corner, just like I drew the original. So I redrew this triangle here. So we've got WZY is another one of our triangles. And then the final triangle that we need to identify is this smaller triangle here. So I'm going to redraw that triangle again. I'm going to make sure that our right angle W goes in the bottom right hand corner, just like I've drawn them here and here. So now that we've drawn all 3 of these triangles, we have the triangle ZXY, we have the triangle ZYW, and we have the triangle YXW that are all similar. So the final thing we need to do is to write these similarity statements. So we're going to write one similarity statement that compares this red triangle to the blue one. So we would draw that triangle ZYX is similar to triangle ZWY. Notice that both of my right angles, so my right angle here is Y and my right angle here is W, and those are both in the same position. The next similarity statement, we need to compare the red one with the green one. So we've got, again, triangle ZYX is similar to triangle YWX. Again, our right angles correspond and they're in the same position. The final similarity statement would be blue to green. So we've got triangle ZWY is similar to YWX. So the answer to number 2, what similarity statement can you write relating the 3 triangles in the diagram? These are our 3 similarity statements that would answer this question. Question number 3 says, what are the values of x and y? So we're going to use this right triangle here, and we're going to need to use some of the theorems and the corollaries that we learned in our notes to be able to set up our proportions, to be able to solve for x and for y. Now for this, to solve for y, we're going to use corollary to theorem 7-3. This corollary said that the length of the altitude to the hypotenuse of a right triangle, so this here, the altitude to the hypotenuse, is the geometric mean of the lengths of the segment of the hypotenuse. So again, geometric mean, we're going to set up a proportion. What it's saying is that the altitude, y, is the geometric mean of the segments. So it's the geometric mean of 4 and of 12, because those are the segments of the hypotenuse. So in order to solve for y, all we need to do is cross multiply. So here we have 12 times 4 gives us 48, and this is equal to y times y, which is y squared. Again, the next thing we're going to do is take the square root of both sides. Now 48, if I take the square root of 48, we end up getting a decimal, so we need to break it down into its factors. 48 has the factors of 16 and 3, because 16 times 3 will give us 48. Now 16 is a perfect square, so that means that we can take it out of the radical. So the square root of 16 is 4, and we cannot take the square root of 3, so that remains underneath the radical. Now the square root of y squared just gets simplified down to plain old y. So we just found here that the value of y is 4 square root of 3. Now for the second part of number 3, we still need to figure out what x is. Now to find x, we're going to use the corollary 2 to theorem 7-3. This one says that the altitude to the hypotenuse of a right triangle separates the hypotenuse so that the length of each leg of the triangle is the geometric mean of the length of the hypotenuse and the length of the segment of the hypotenuse adjacent to the leg. I think this one is the hardest one to understand. So again, all this is saying is that one of the legs, so for example, this leg that has the length of x, is the geometric mean of the hypotenuse and of the segment of the hypotenuse that is adjacent or next to the leg that we're talking about. So that means that the value x, that leg, is the geometric mean. So the leg x is the geometric mean of the hypotenuse, which is 12, and the segment of the hypotenuse that is adjacent to the leg that we're talking about. So to this leg, the segment that has a length of 4. Now as always, from here we need to cross multiply. So we take 12 times 4 and set it equal to x times x. So 12 times 4 is 48, and that should be equal to x squared. Again, this is the same one we did before, well, where we had 48 as our x squared or as our y squared in the last one, so we square root both sides. Again, we said that 48 broke down to 16 and 3. So this ends up being 4 square root of 3 is equal to x. Our final question says use the figure to complete each proportion. So we're using this figure here. We're going to actually do this one in class together, but I just want to identify a couple of things first. So we know that J is the hypotenuse. We know that this is a leg, and that is D. And we have another leg, F. And then finally we also know that the segment in the middle, right here, this E is the altitude. So those are all really important things we need to be able to identify in order to help us complete the rest of these proportions.